Today, we're going to talk about stupid little dots. All right? Let me tell you right away, decimals. Those stupid little dots are nothing more than stupid little dots. However, they are important little dots. They're very important. Because think about this. When you get a paycheck, if that stupid little dot's in the wrong place, you're either really, really happy or you're really, really sad. But let me tell you something about these stupid little dots. These stupid little dots don't change anything about how you do things, how you do your addition, how you do your subtraction, how you do your multiplication, or how you do your division. It doesn't change a thing. Okay? All the operations are the same. Now, the first thing we need to talk about is place value. You all know place value to the left of the decimal point. For example, this number, 37156, right there. How would you say that number? 37,156. What is this place right there? That's the ones place. What is this place right here? Tens place. What is this place right here? Hundreds. What is this? Thousands. Thousands. What is this place? 10,000s. Notice nobody spit when they said any of those things. Why do I say spit? Because everything to the other side, 0.3715. Now we're on the other side of the decimal. This one is what place? That is the tenths. What is this place? Hundredths. What is that place? The next one? Thousandths. Ten thousandths. One, two, three, four, 5. 100,000ths. Okay. Over here on the sideboard, I have written down all. Well, not all, but I've written down. First of all, you might recognize this as pi. 3.14159265358. Thank you. Okay. Pi actually will continue on forever and ever and ever, but I stopped at the trillionths. We got tenths, hundreds, thousands, 10,000, 100,000, millions, 10 millions, and so on. Notice everything at the end, everything to the right of the decimal point ends in a THS. That's how you say that place value. Place value is very, very important. Place value is how you end up saying some of these things. Let me show, for example. The next slide. You're going to be asked, on your homework, you're going to be asked, you need to write each decimal in standard form, expanded form, and words. Well, this one right here, what form do you think that is right now? That's in standard form. That's how you see it every day. That's regular, normal, standard form. Now, the hard part comes for many sixth graders in figuring out how to say this. These are numbers. Let's change it to words. Remember we had before the last chapter, we talked about going from words to numbers. Well, now we're asked to go from numbers to words. This little dot right here, what word is that little dot? And. So that little word, that little dot means and. All right. What is this right here? 1. So we put 1 before the and. Because it says 1, if you read this, it would be 1 and. Now, what is this number right there? Tell me what that number is. No, what is that number right there? What is it? 7. 1 and 7. Now we need to know what to say. We need to decide which it is. And the way that we do that is we count the number of places. This is 1, 2. What place is that? The second one to the right of the decimal. Yeah. Hundredths. 1 and 7 hundredths. So we say these things with, we say this number normally, 7. 7, and then we choose the place value that it is, and we say that. We choose the place value of the last digit, which is hundredths. 1 and 7 hundredths. Now, expanded form gets a little bit more complicated. If we had our, let's just say we had this number, 371, 371. If I asked you to put this in expanded form, Alexis? Now, I have this number, 371. If I asked you to put it in expanded form, I would have 300 plus 70 plus 1. Notice I go 3 digits, 2 digits, 1 digit. If you're to the left of the decimal and you do expanded form, you go from largest number of digits to the smallest number of digits. Now, if I changed this, and I have this decimal here, expanded form would look like this. 0.3 plus 0.07 plus 0.001. Notice I go 1 digit, 2 digits, 3 digits. See how it's the opposite? Let me show you some other trick that you can do when you do this expanded form, because expanded form with decimals gets to be kind of hard for some students. Notice if I put it up and down, I do 0.3 plus, and I always line up decimals. Always, always, always keep decimals in the same line. Okay? 0.3 plus 0.07 plus 0.001. Notice my diagonal is the number. You see that? So always, and notice I only have 1 digit on each line that is not a 0. 3 in this line, 7 in this one, 1 in that one. So I'm going to change this number just because I don't want to confuse anybody. I don't want it to be 1.07. I want it to be 1.17. What would it look like in expanded form? 1 plus 0.1 plus 0.07. Let me put it on the diagonal. 1 plus, notice I'm going to line up my decimals, 0.1 plus 0.01. 7, I mean, sorry. Notice my number is right there on the diagonal. Okay? So the first thing I want you guys to do on your whiteboards is I would like you, first of all, give me the standard form of that number right there. If you added all of these together to get standard form, you would have your decimal right here, 0.03 plus 0.006 plus 0.0009. To get standard form, you added all those together, and you end up with a 0.0369. Okay? So there's your standard form. As far as written, I would like everybody on their whiteboards underneath their answer to tell me what this is in words. Tell me, what is this number in words? Everybody, because I saw a lot of people struggling with this. All you need to do is read this number. What is this number right there? What is that? That number says 369. So that's all you need to do, Alexis. All you need to do is write 369 because that's this number. That is the number. So 300. Oops. Put an R in there. 100. 69. 369. Now we need to do is we need to look at the last digit, this last digit right there, and we need to figure out what place is that last digit. Now you guys are so used to having 4 digits be thousands. But be careful. On the right side of the decimal point, it's different. This isn't thousands. This is tens here, hundreds, thousands, 10,000s. So we put 10,000s here. Okay, next slide. On your whiteboards, first of all, I want you to write it in standard form. Okay, most of you can get this. 14.08, because this 8 is in the hundredths position, so we know that we have to have a 0 in front of it. So 0.8. Now, expanded form. See if you can do expanded form on your whiteboard. First of all, before you get too far, a bunch of you are going to start out by going like this. 14 plus If I asked you to put 14 in expanded form, how would you do it? 10 plus 4. Then move on from there. Okay, so a lot of you got it. 10 plus 4 plus 0.0 plus 0.08. Many of you made this mistake. Had 10 plus 4 plus 0.8. You forgot about this 0 here. Remember, if it helps you, I would like you to do it this way. 10 plus 4. You can do it up and down. Notice, if I was to put a decimal at 10, it would be right after the 10. If I was to put a decimal after 4, it would be right here. Continue to have your decimals lined up. Plus 0.0 plus 0.08. Notice, my answer is on the diagonal. And I always only have one digit in, one non-zero digit in each one. Yes. You do not need, that's a very good question. He asked, why do you need that in there? You don't need that in there. You don't need that 0.0. This doesn't have to be there. However, I ask if you want to put it in, because it will help you keep track of where you are. On your whiteboards, I want this in words. And I want, below it, I want this in standard form. Okay, for A, it is 1 and 12 hundredths. For B, for standard form, it's... Can someone tell me what this number is? How would I say this? How would I say this? How would I say this? 10,000. 6,000. Notice, I just look at this number. 6,087. And then I count out 1, 2, 3, 4 places. The fourth place past the decimal point is 10,000. So it's 6,087 10,000ths. Now, I'm not done yet, and if the bell rings, I want you to hang on for a minute. I want to show you a couple more things. Okay? It says, well, whatever. It's asking which one's bigger, 13.5 or 13.05. Which one is bigger? Which one is bigger? This one's bigger? You are correct. This one is bigger. It's just like 135 versus 130. You look at it that way, 135 versus 130. Start at the left, go to the right. If the numbers are the same, this one's the same, so we can't figure it out. We don't know which one's bigger. This one's the same. We don't know which one is bigger. Uh-oh, these two are different. Which one's bigger? Oh, this one. So that means that this whole problem is bigger. Next one. Same thing. We have 11.3 and 11.03. Which one is smaller? 11.03 is smaller. Because we looked at these two numbers right here, 1 and 1. Those are the same. These are the same. Oh, these are different. I asked which one's smaller. 0 is smaller than 3. That means that this one is. You have an assignment. Your homework assignment is page 110 to 111, 10 to 40 even, and 45 to 50 all.